All right, when we're looking at the three-dimensional shape of a molecule, there's really not that many you're responsible for in this class. It really comes down to just these 5 that we're going to look at because these are the only 5 made possible by the octet rule. So you will typically see molecules that take a shape that is either linear, bent, trigonal pyramidal, tetrahedral, or trigonal planar. Just to get a closer look at what these things are, a linear shape is precisely what it looks like. A linear shape will typically be seen when you have something that is straight. After all, linear basically means straight. It is a shape more or less like this. So observe the form that this molecule has. Actually, even this is, in many cases, difficult to achieve with the octet rule, but nonetheless, this is, if something was linear, this is what the shape would be. Now, bent, just to be clear on what that means, refers to a shape that looks like this. Here I have a model with springs and small wooden balls that represent atoms. Oops. So just to be clear on what it is, bent is, well, just simply this. This is a bent shape. Right? That is bent. Now, what is this business with trigonal pyramidal? What does it mean? First of all, the shape trigonal pyramidal is, if you look at just the atoms and ignore any lone pairs that might exist, it is this, where there are 3 evenly spread, but you may notice that trigonal pyramidal, they are not all flat. They are a little bit pointing downward. I suppose another way to visualize it might be with a different model I have constructed, which has them in a little bit more of a obvious how they're not flat, they're bent downward, because I'm trying to contrast this with trigonal planar, which looks more like this. You'll notice trigonal planar is flat, trigonal pyramidal is not. They both have 3, but trigonal pyramidal has them all kind of pointing downward. I guess it depends, upward, sideways, whatever, but basically not in the same plane, not flat. After all, planar sounds like the word plane, which in geometry means a flat surface, because the trigonal planar is flat. And finally, I can end with tetrahedral. Here's a model of tetrahedral. Tetrahedral is just a shape where you have 4 atoms coming off of a central atom. So this is tetrahedral. And the thing about tetrahedral, let's see if I can find a convenient surface to use, is that a tetrahedral shape does not change regardless of its orientation. So notice 3 down, 1 up. Flip it over, same thing, 3 down, 1 up. Flip it over, same thing, 3 down, 1 up. No matter how I flip it, no matter how I rotate it, it's always 3 down, 1 up. This is a classic tetrahedral shape. Here is another different model which kind of gets to the same idea. Oops, I accidentally dropped a piece. Yeah, oh well, it works. Let's see. Here we go. Also tetrahedral, also getting at the same idea. It's 4 atoms branching off a central atom. So this is just the quick introduction to what the basic molecular shapes are that you're responsible for in this class.